Welcome to Day 5. Today, we're talking about a problem that every single person working with data runs into: missing values.
So you've got a data set, and it's got nulls sprinkled throughout. What's the first thing you think of doing? For most of us, it's just drop the rows, right? Or maybe fill them in with the mean. Simple.
But hold on, that quick fix can introduce some really subtle and sometimes serious bias into your analysis. See, the right way to handle missing data has less to do with the method you choose and everything to do with why that data is missing in the first place.
By the end of our short time here, you're going to have a clear mental framework for diagnosing exactly what kind of missing data you're dealing with. We're going to unpack the 3 core mechanisms behind it.
Okay, let's build up our intuition with a simple story. Imagine you're running an experiment and you're using a digital weighing scale.
All right, scenario 1. The scale's battery just dies, completely at random. You lose a measurement and it has absolutely nothing to do with what you were weighing. It's just plain bad luck.
Okay, scenario 2. Now, the scale only seems to make errors when you put it on a soft, wobbly carpet. On a hard, stable floor, it works perfectly. So the failure is predictable if you know what kind of surface it's on.
And for our third scenario, let's say the scale's internal spring is worn out. It starts failing to record a weight, but only for really heavy objects. The failure is directly related to the weight itself, the very thing you're trying to measure.
So these aren't just quirky equipment failures. Each one of these scenarios is a blueprint for a distinct and predictable pattern of missing data, and you will see these patterns everywhere.
So now that we have the intuition, let's connect it to the formal terms you'll encounter out in the field. Our story maps directly to the technical terms. That random battery failure, that's what we call MCAR, or missing completely at random. The scale failing on the carpet, that's MAR, for missing at random. And the scale failing only for heavy items, that's MNAR, or missing not at random.
Let's dig into these. MCAR is the simplest case. It means the probability of a value being missing is the same for every single observation. The missingness is totally unrelated to any data, whether it's the data you have or the data you don't.
Next is MAR. Now this one has the most confusing name, by far. It does not mean the data is missing randomly. Instead, it means the reason for the missingness can be explained by other variables you've already observed. Just like knowing the scale was on a carpet helped us predict the failure.
And that brings us to MNR, missing not at random. This is the trickiest one. Here, the chance of a value being missing is related to the value that's missing. A classic example is from surveys. People with very high incomes are often less likely to report their income. The very value you're missing is the reason it's missing.
So here is the crucial difference, boiled down. For MGAR, you can predict the missingness from other data you have. For MNAR, the missingness is linked to the data you don't have. That's the mental model to hold on to.
Okay, so we have these labels. Why should you, as a practitioner, actually care about this distinction?
Well, it matters because your strategy depends completely on which of these mechanisms is at play. If your data is MCR, sure, you might get away with just dropping rows. But if it's MAR, you need something smarter, like imputation. And if it's MNAR, that's the most difficult scenario. If you get this wrong, you're just silently introducing bias into your work.
Let's make this concrete. Imagine a medical study where you notice participants from rural areas are more likely to miss their follow-up appointments. The data for that appointment is missing, but you know their location. Since the missingness is related to another variable you've observed, this is a classic case of MAR.
All right, let's bring this home with the single most important idea to remember.
The golden rule is this: you have to let the underlying reason for the missing data guide your strategy. Always diagnose the why before you even start to think about the how.
So the key takeaway is a simple shift in your thinking. Stop asking, is my data missing? And start asking, why is my data missing?